300 megawatts is to be transmitted from the Hazelwood Power Station to Melbourne along a transmission line with a total resistance of 1 ohm. What would be the total transmission power loss if the initial voltage along the line was 250 kilovolts? Okay, so there's a couple of things we can do here. Our initial voltage, VI, is 250 kilovolts. All right, our power initial is going to be 300 megawatts. And we know that our resistance in our lines is 1 ohm. Okay, so there's a couple of ways we can go about this. You can use the formulas on the previous page. I personally like using Ohm's law just because I find it really easy to remember. So let's work out what the current in our line is going to be. Okay, so remember that P equals IV. And so I is going to be P over V. 300 times 10 to the 6 divided by 250 times 10 to the 3. $1,200. I get. So we've got 1200 amps. And so, remember that equation I gave you on the previous slide? Our voltage drop is equal to, voltage drop is equal to IR. We know our I is 1200 amps and our R is 1 ohm. So we are going to lose 1200 volts in our lines. And so, once we get to the other side, we've lost 1200 volts. And so our power loss is our change in voltage multiplied by our current. So our change in power will be 1200 multiplied by 1200. So what is that? 1.44 times 10 to the 6. So there we've got our power loss. 1.44 million watts we've lost in that transmission. Now, as a percentage, it's not that high. It's about 0.5%, because we started with 300 times 10 to the 6, because we've got a pretty high voltage. Okay? So this is the main point. Again, high voltage leads to low power loss. And even though that power loss looks large, it's not too bad as a percentage. Okay? But that's how you can work out something like this. There are other ways you can do it with the previous equations on the previous slide that I gave you. But yeah, that's the general idea.